It is time for Subnautica Biology with Chameleon. Greetings, ladies and gents, and welcome back to Subnautica. You see, I do not have, again, just like the previous episode, my goggles on my head because we are going to read. And who needs actual goggles if we are going to read our PDA? Let's go check it out again. This is again an episode where I'm going to read about the non-essential things. This basically only leaves us with the indigenous life forms, the fauna and the flora. So let's get into it. The fauna. Wait, I've already read about the carnivores, the leviathan. So yeah, we were at scavengers and parasites. The cave crawler. That's right? Yeah, because we read the reef back. Oh, right! The cave crawler. Oh, weren't those the things we found on the beach near the alien ship? I'm pretty sure. Cave crawler. Agile, territorial, carrion feeder. Well adapted to both land and sea. 1. Gas exchange membrane. So that's the membrane it has around. It's nice that we can see this picture above the text. So we know number 1 and number 2 what they're talking about. So this is the membrane, like the skin. Absorbs essential gases from the air or water for basic bodily regulation. Oh, that's nice. So you have a semi-permeable skin then. Mandibles. This species seeks out corpses in packs before defending its claim while the corpse is devoured. So you're like a scavenger. You're a scavenger eater. Assessment. Necessary waste recycler. Avoid or incapacitate. Yeah, I already figured that. Let's go to the floater because you look cool and scary. The floater. 2 species living in symbiosis, which attach to and attempt to feed on any objects they come into contact with. Wait, these are two creatures in one. Dominant life form. The pink main body and inner suction jaw is the dominant creature. Once attached to an organism or other stable surface, it will attempt to leach nutrients in order to grow. Can you do the same thing with the rocks then? Because I see these rocks floating around because of the floaters. Is that because of you? Microorganism membrane. The outer gel-like substance is a mesh of microorganisms capable of forming a sealed vacuum around the creature's jaws. Alright then. Helium buffer. A thin layer of helium is stored within the outer membrane, providing buoyancy to the floater and anything it is attached to. Why helium though? Why not oxygen? That would make more sense, right? Would it? I mean, both oxygen and helium will let it float in the air. Because, or in the water. If it's now helium, then if I throw out a floater in the sky, will it just float up? Because it's helium. Assessment. May aid in flotation of sunken objects. I guess it will not do that because it's also heavy. It's like much heavier than a balloon. So, the shuttlebug. Oh, you are those kind of creatures. Yeah, I remember you. You're really weird. You're really weird. The shuttlebug. A common scavenger at the base of the food chain. Mouth parts. Which is number 1. Where is that? Alright, so that's really in the center of your body then. Well, kind of in the center. On the top of the pillar, so to say. Small enough to be of little threat to most organisms, this creature is clearly adapted... Wow. Sorry. I'm so sorry. I'm so sorry about that. This creature is clearly adapted to feed on the waste products of the ecosystem around it. 3 mandibles. Used to orient themselves when drifting and to filter through detritus on cave floors. Detritus, sorry. And 3 legs. High strength muscles can propel the life form great distances through the water, as well as accumulating them across the sea floor. Assessment. Necessary waste recycler. Presence may indicate nearby cave system. So these guys are like the cave crawler, but then the water variant, because they are both scavengers. And they recycle all of the nutrients in the system, like the dead bodies and such. Cool. On to the flora. Exploitable. The acid mushroom. So these are all the things that we can actually have a use for then. That's good to know. The acid mushroom. A common spore-bearing fungi species. The flesh contains a highly acidic compound which leaches into the water if the outer skin is penetrated. It is not clear which predator species necessitated such extreme countermeasures, but the acid mushroom's numbers suggest it has successfully deterred most of them. Assessment. Inedible. Acid has applications in battery fabrication. Yeah, we know that. The Balbo Tree. Oh, that's the thing we again found on the beach, right? A bulb-based flora with roots to the ground and sprouts turquoise leaves. Analysis suggests the sap produced by this plant is poisonous to insects, but can be harvested and consumed by humans for its high water content. Oh! Assessment edible, high water content. I could eat that thing? Well, I should have known before. The Creepvine! Oh, I love you. We are actually near a Creepvine biome, kind of. Is it a biome? Is the Creepvine also a biome? I guess. A kelp species concentrated in large forests, in shallow, sandy waters. Loose roots anchor the plant to the sea floor, from where it grows steadily toward the surface in pursuit of sunlight. The stem is fibrous and rich in iron, making it both a viable base material for fabrication of textiles, as well as a basic foodstuff. Assessment. Vital alien resource. Edible. Construction applications. You can eat Creepfine? I don't think I've eaten Creepfine before. Creepfine seeds. Oh, that's funny that they just made a separate log for that. I thought we would just join it together. Mature creepvine plants that have survived the predation of small herbivores produce these bioluminescent seed clusters, which may be knocked loose by currents or consumed and later deposited by predators. Is there a fish there? What the fuck you do? Oh, god damn it, my food! Wow, my voice is getting all high pitched again. I was looking at my food. Alright, we're on the second paragraph. The embryo is surrounded by a thick oil and silicon layer, which would disperse into the ground as the outer skin deteriorated. This may provide the seedling with the nutrients it needs to survive the low light conditions on the seabed. Assessment. Vital alien resource. Construction appliances. So, applications. Whew. So, wow. I'm so sorry about that. It's early in the morning, guys. It's just before I go streaming, actually, but... You know, I wanted to finish this off before I start streaming. So, that's funny. So, there's a seed in there. And when it lets loose off the vine, it goes to the floor. It is like an embryo sac. It has all its nutrients the seed needs. And then when it is completely dispersed, the seed has grown. And we have a new plant. That's cool. And this sulfur plant, which, of course, is related to that other... what was it? Was it the carnivore? Was it the crashfish? Yeah, exactly. The crashfish. The crashfish. Damn. These plants appear to serve as nests for the explosive organism which guard them. Yeah, like I said. The outer petals are undamaged by the presence of the inhabiting creature, suggesting a complex co-development. The plant has evolved to feed on nutrients and minerals deposited within it by the fish. Sulfuric deposits on the inner leaves provide an insight into the mechanism by which the creature explodes. Assessment. Sulfur has applications in construction of the repair tool. Yep, we knew that. Now, the sea. That's a lot. Anchor pods. Oh, right, those were the things I thought they were mushrooms first, until we actually found a mushroom biome. Let's see. Anchor pods. These unusual flora specimens have been encountered exclusively on the deep reefs. They consist of a large, spherical, gas-filled membrane anchored to the seafloor by its root system. So they are like balloons. At these depths, it is unlikely that structure is designed to enhance access to sunlight, but rather the pod's ability to propagate. Once the pods attain sufficient height, they burst. Now that's bad. Can we see that in game? That would be cool. Releasing spores which catch the currents and disappear around the local sea. Okay, cool. The blue palm. The blue palm is a common aquatic plant, which thrives in shallower waters with high exposures to sunlight. Long fronds intercept light before it can reach the smaller flora on the seabed. The drooping stinger. We have a number 1 and a number 2 again. Number 1. 0 photosynthetic cells detected. Implies carnivorous adaptation to low light environments. Nice! So yeah, that's the first one we actually find that doesn't use the sunlight. Follicles along the tentacles are capable of detecting contact with foreign bodies, triggering an electromagnetic charge in the 600 watt range. Prey is likely paralyzed and consumed over many weeks. Oh, I'm yawning again. I'm so sorry. This makes the Let's Play very boring. Ah! Wake up! Prey, small fish. Assessment, avoid. It reminds me that we have flesh-eating plants in our home as well. Like very small ones. Like the fly trap, for example. You can look it up if you don't know what it is. It's kind of cute. The jelly shroom. Yeah, these things were amazing. A life form unique to a microcosm located in a cave system deep within the grassy plateaus, where a high concentration of carnivorous life forms wards off smaller predators. Consists of a tough, trunk-like base from which grows a fragile purple membrane. Membrane structures suggest vulnerability to predation, but evidence thereof is lacking. Unknown defensive mechanisms, possible symbiotic relationship, predators non-identified. Whatever, man, these guys are cool. They're very... The jelly shroom, they're the best. Oh, the membrane tree, that thing was really weird. The entity defies neat categorization. It consists of more than one coral species working in tandem to create an insulated microcosm enclosed within a translucent membrane. Found exclusively growing on basalt rock in the Grand Reefs, the homeostatic conditions within the homeostatic conditions within are considerably warmer and more dense with a microbial life than the outside environment, and the bright purple fauna inside will likely die off quickly if exposed. Right, it's its own little world. It's really cool. The redwort. A common plant adaptable to many different environments. The redwort is a staple part of the diet of many smaller herbivores. And that's all we know about that thing. Just like the regress shell. This specimen is composed of a complex series of regression rings connected by tendrils. Indeed, I can see that. The rough cradle. Well, if they are also short, we're gonna go fly through these in no time. A complex, cave-dwelling flora specimen. The bright yellow core of this plant is protected by a rigid cage, presumably to ward off medium-sized herbivores. Spiked horn grass. Yeah. While it shares a close genetic similarity with bloodgrass, this species has developed to house its root system in rigid, horn-shaped enclosures. It's almost like it has its own shell, like snails, you know? It's cool. The tree leech. Parasitic, fungus-like growth found attached to other life forms. An enzyme is released by the organism, which dissolves a hole in the skin of the host, from which it leaches nutrients directly. Ew. Outer, tooth-lined jaw serves to no identified purpose. May be used during a different stage of the organism's life cycle. Assessment, exploitable fungal enzymes. I can actually do something with that thing? Where did we find this? I cannot remember where we found the tree leech. Was that also on the surface on the beach? A veined nettle. The veined nettle, a common shallow water plant, which frequently shows signs of predation around the edges of the leaves. Thick, violet veins carry nutrients to the extremities of the fan, and brightly colored seeds grow around the base and stem. Yes, it does. It's kinda cool. The violet bow, a common luminescent plant which grows in patches on the seabed. And the writhing weed. The writhing weed, well adapted to both shallow waters and cave systems. This plant lives in symbiosis with a coral species which forms around the base of the stems. We don't have a picture of that though, it's kind of a shame. Alright, so we actually read everything of this now. We can close the flora, we can close the fauna, we can close the indigenous life forms. There we go. So, that was it for the reading. I'm probably going to hunt for some food and water right now. And then in the next episode we are going to go into the more lore-based things of the game that apparently are very important to the Let's Play itself. So if you probably, because I say this at the end, you do want to watch that third one. So that will be about the advanced theories, the data downloads, and yeah, that's it. So this one and this one, these two that are still left. We're going to read all of them and see what kind of lore we can find. But for now, I'm going to leave this episode here and go hunt for some fish and water, and then I'll see you in the next read. So this one is a little bit shorter. I did not think it... I thought it would take a longer time. There's a lot to read here, so I hope you guys are enjoying it, but otherwise, like I said, you could have skipped the videos, of course. So if you're still here, kudos to you. Thank you for listening. And, well, for now, thank you so much for watching. If you like this episode of me reading about more marine biology in Subnautica, then give it a thumbs up, and then I will see you in my next video.